In today's video, we're going to explore parallel circuits, and in particular, we'll consider how they treat potential difference, current, and resistance. Parallel circuits are those with more than one loop, and generally each loop will only contain a single component. This makes parallel circuits much more useful than series circuits, because as each component has its own loop, if any particular component breaks, then the overall circuit is still intact. For example, if one of the lights in your house blows, all of the other ones will still work. Often though, circuits will be a mix of series and parallel parts. So although we might have multiple loops, we could still have more than one component in some of those loops. If you're not sure what series circuits are, then it's probably worth checking out our video on that first. We put a link to it down in the description. Now, the first thing to know about truly parallel circuits, so those with only one component in each loop, is that all of the components get their full source potential difference. So if we have a 12-volt battery, then all of the components will have 12 volts across them. The next thing to know is that the current is shared between all of the loops. So if this circuit with two loops had a total of 4 amps flowing through it, then it could be that there were 3 amps flowing in the first loop and 1 amp through the second, or it could be equally split and have 2 amps flowing through each loop. Either way, if we add the currents in each loop together, it will always add up to the total current of the circuit, in this case 4 amps. The way that the current splits will depend on the resistance of the individual components in the circuit, with the loops that have greater resistance taking a lower share of the current. You can think of this as if the current is water flowing down a hill. If the water can flow down 2 possible paths, then most of the water, which represents electrical current, will take the path of least resistance, which is why we get a higher current flowing through the lower resistance loops. The last thing we need to look at is resistance. One strange thing about parallel circuits is that the more components we add in parallel, the lower the total resistance of the circuit will be. It's a pretty odd concept, and it could just be one of those facts that you have to accept and remember. But it might help to think about it in terms of our river example. Imagine that we add another possible route for the water to flow. Even if this route has a high resistance, it still increases the options for our water to flow, meaning that the water can flow down the hill more easily, which is the same thing as saying the overall resistance has decreased. So in physics terms, the more loops we add in parallel, the lower the overall resistance will be, even if those loops contain big resistors.